Okay, before we get into actually using exponential functions, we need to do some definitions and some review. So first, let's review domain and range. Remember, domain are all values of x where a function is defined. It's what we can plug into the function or input into the function and get an answer. Our range is all values of y that a function achieves. It's the values that come out of a function, so it's the output, once we plug the x values in. And remember that f of x, or h of x, or g of x replaced y in our equations because we're using function notation. With our domain and range, we are only going to be paying attention to the real numbers, not the imaginary numbers. If you want to do that, take complex analysis as a math class. Okay? And to identify our domain and range, we're going to be using interval notation. Interval notation is used to identify all of the values a variable can be for a function or inequality. And we say a variable because it could be x, it could be y, it could be f of x. So we're not going to say it's just for x, it's just for y. It's just whatever variable you have. Okay? And in the form, we're going to have parentheses, and you always put your smallest number first with a comma, and then our largest number. And just keep in mind that you're going to have parentheses or brackets or a mixture of the two. A parenthesis is used when you cannot actually get to that boundary number. And parentheses are what I was just using. So something like that. So you can't actually get to the boundary number. And you may be wondering, well, what do you mean? Perfect example is when you have positive or negative infinity. We can't actually get to infinity. There's always a number bigger than the one that we're thinking of, or smaller if we're going negative. So we would always use parentheses with our infinity. Always. It's not an option, it's an always. But we can use brackets when we can actually use that boundary number. So we can plug it in. And brackets look like closed parentheses, but keep in mind that we also said this could be a mixture of the two. So you could have something that looks like bracket, comma, parenthesis, or parenthesis, comma, bracket. I know it's odd, but that's okay. We can mix and match as we need to. Okay. Now, let's talk about exponential functions, what this whole thing is about. They are in the form f of x is equal to b to the x, where b is a positive real number not equal to 1 or 0, because that would be lame. Okay. You know that you have an exponential function when the variable is in the exponent. Okay, so another way to look at f of x, if you're getting confused about the b for the base, it is just some number, some constant to the x. Our variable is being held hostage in the exponent. Okay, and then my favorite function, we have our natural base, e. It's an irrational constant like pi. You know how pi is 3.14159, blah, 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 blah. E does the same thing, but it's 2.71, so forth, so on. We have an exponential function, the natural exponential function, and this is the natural one because it actually shows up a lot in nature, would be f of x is equal to e to the x. Now remember, e is not a variable, it's a constant. It's not going to change. And there is a button on your calculator for e, and we will discuss that more in the next video.